All right. So I'm using the packet here, and we're going to go through all the answers. If I don't finish now, I'll finish it later. So here we're going to talk about the domain and range of this graph. The domain is going to be all the x values it hits. So from here, it starts at 1, 2, 3, 4, -4, all the way over here to 3. So the domain is a hard bracket because it has a solid point at -4, 2, 3, hard bracket because it has a solid point here. If it has an obviously open circle like this, it will be a soft parentheses, okay? But it doesn't have that, so. All right, the range in this case is over here. It's going to be how high you go and how low you go. So the highest point I get to is over here, which is 4. And the lowest point I get here is -2. So my range is going to be a hard bracket, -2 to 4. All right. So with this f of -4, I look at where the x value is. So the x value is -4. So I go to the x value -4 and I take the y value from here. In this case, it is at 1, 2, 3, 4. So the answer here is 4. Over here, I take the x value and I'm going to get at 1. So over here, at the x value 1, I'm at -2. Now, I want to talk about where it's increasing. So increasing, remember you read the graph from left to right. So it seems like it's increasing in this section over here. So I checked it out. The official way would be a soft bracket. So a soft bracket from 1 to 3, soft bracket. If you mess up on this part, I will not take points off because I did not tell you when I first taught it. But it technically should be soft bracket because you're not actually increasing on 1. You're just standing still on 1. And then where it's decreasing? Decreasing should be where it's going down from left to right. So we take the x values. So this is going to be from -4 to -2. Any questions on that first part? X values. You take the x values. Yes, because I'm talking about in what section, like this way, side, like left to right. What segment is increasing? If I ask how much it would increase, that would be y values, but I don't ask that. All right, the next one, I'm going to go quickly because it is the same concept repeated. From here, it is 3 to, this is 2, 3, 4. So -3 to 4. The range, the lowest point seems to be, this is 3, so this would be 2, -2, and this highest point should be 4. So -2, 4. F of 4, 1, 2, 3, 4. Oh, this is up to 6, my bad. This is up to 6. Up to 4 here, so that's at 0. Now here is increasing in multiple places. It's increasing here. Oh, here.
How is that 6?
And here. I'm sorry, because it's 1, 2, 3, 4, 5, 6. It actually goes to 6. So it's increasing in all the red sections. So I'm going to say it's increasing from starting at -2 or -3, my bad. Soft bracket, I'm sorry. Yeah, you're right. Old habits die hard. -3, all the way up to 2, it's increasing. Then you're going to put a little comma in between because we're going to continue from 4 to 6. So all the red is increasing.
So it didn't matter that it went like this.
No, because that's still increasing before and after, so it's increasing overall.
Oh.
While here, it's decreasing only between 2 to 4. Last one on this page. Domain from 0 to 5. The range, the highest point is 5, the lowest point is 0, so also 0 to 5. Is it increasing in all the red segments? So here and here. So soft bracket starting at 1 to 2, comma, and then 4 to 5. It's decreasing in all the green parts. So that is 0 to 1 and 2 to 4. All right, next page. Okay, this is more of the practice over here. I just want to talk about whether it's a function or not. Remember, the rule for a function is a vertical line test. So if it passes the vertical line test, then yes, it is a function. While something like number 5 over here, where the circle is, this is not a function because it fails the vertical line test. So that would be a no, not a function. Otherwise, this is more practice on the domain and range stuff. Is there anything particular I want to talk about? One thing I want to talk about, number 7. You can see the open circle's the farthest to the right, which is 3, while the farthest to the left looks like a -4. So the domain will be a hard bracket, -4, comma, 3 with an open parenthesis or a soft parenthesis. Reason is there's an open circle at the 3 of the x values. If it has arrows, you have to assume it goes on forever. So for like number 8, the domain is negative infinity to infinity. And the range is negative infinity. Oh wait, no, the range is the lowest point. It's going to be here, which is 3, -3, to infinity. Yes.
What's 4? Is it a function?
4 would be a function still. It still passes the vertical line test, even though there's not dots connecting it.
Wait, what's the domain for that?
Oh, for number 4, the domain. So the domain here, there's no coordinate points here, right? Like there's no line. So usually you will not get a question like this, but the real answer is you put this swirly bracket here. This means you're talking about particular points. So the domain would be at -3, -2, 1, 2, and 5. Those are all the x values that occur if you were to take the order pairs. But you're not going to get problems that are dots.
So the range would be the same thing?
Range would be all the y values, so, but yes, the same thing.
Yeah.
Yeah. And you wouldn't have to repeat. So here you have 2 pieces of range that is 1. You don't have to repeat 1.
Wait, is the negative split on number 8? Is that a hard bracket?
That should be a hard bracket, yes. Because it actually hits -3. It's like flat on -3. Okay. All right. I'm going to go into the next page because I don't want to spend too much time on that. All right. This one. Shifts. If this looks familiar, this is from your review last year. Gives the shifts of this equation. So there's a couple of things happening. First, the 6 is in front. The 6 in front means it's going to be a vertical stretch by a factor of 6. So a vertical stretch of 6. Over here, this -5 next to the x means we would think because it's negative, it goes to the left. Remember, it's always reversed. So it's going to go to the right 5. And then over here, this blue, for the blue, the +3 will mean it will go up 3. Because whatever value happens over here, I just add 3 to it, so every number gets artificially up 3. The domain and range, remember, an exponential function looks like this, where it has like a horizontal asymptote at typically line 0. But because this thing is shifted up 3, the domain is still all real numbers, aka soft bracket, negative infinity to infinity. But because this is getting shifted up 3, the asymptote is also getting shifted up 3. So it's no longer at 0. The asymptote will be 3. So the lowest value it ever reaches is 3. So range is going to be a soft bracket at 3, because it never reaches the asymptote, and it goes up forever to infinity. Never reaches the asymptote. So it's a soft bracket for that.
Oh, yeah.
Yeah. Okay. All right, for this one, we're going to solve for this. First thing I'm going to do, when you see a log by itself, put a little 10 underneath it because it's automatically a visible 10 to help you work on it. Now, I want to solve for x. You could technically put this in your calculator, but to do it by hand, you would take the 10, move it over here. So we get 1 over 100 equals 10 to the x power. Then you ask yourself, how do I get to the denominator? I need to be a negative. And then I need 10 to become 100. So that'll be 2. So the exponent here would have to be negative 2, which means x equals negative 2. Okay. In number 4, I take the 16, move it to the other side. So x equals 16 to the third fourth power. To do this, remember, anything to the denominator of an exponent, we could rewrite as a root.
So the cube root of 16 to the 4th.
Almost. The fourth root of 16 to the third. The denominator becomes a root, while the exponent, the top part, the numerator, stays the exponent. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 will give you 16. To the third power means this is 8. So x equals 8 in this one.
Why'd you do the square root for the exponent?
It's a little easier because you could technically use 16 to the third power and then figure out what multiplies to it.
You do it either way?
You could do it either way, but definitely easier to root first, then power.
Okay.
For these, I say you have a calculator. You're not forced to have a calculator, so these should be all solvable by hand. All right, this one is an expand question. So I got to expand this. So when you multiply things, that means you're adding them. So ln x plus ln y to the third plus ln z to the second. I have these exponents up here, which means I'm going to move them in the front. It is ln x plus 3 ln y plus 2 ln z. Guys. So, after you basically want all the logs or ln's to have only a variable inside or a number inside. So in this case, is expanded completely.
Can you solve last part? Not solve, but like.
This one?
No.
There's nothing equals to, so I can't. Yeah. ln2 is a number of some sort, but you would need a calculator for that. I'm not asking for that. This one, we have multiplication and division. So I'm going to rewrite this as log 3 because it's times log, not times, I'm sorry, plus log x to the 5th minus log 10. This one will have to move to the front. So this is going to be a 5 log x. And then log base 10, 10, you can reduce down to 1. I probably would have taken a point off, but that's the most proper way to do it. Okay. So that's expanding. We're spreading them out. Now let's go condensing, the kind of reverse. So there's this subtraction, so that means it's division. So log base 5, 8 over t. Remember, if it's a base 5, you got to be consistent with the bases. Actually, I want to change my statement. There may be questions where they are simplifiable. I would like you to simplify it if possible. So like log base 10, 10, I would like to change to 1. That's done because it's all in one log. We're happy. This one, 2 is going to go up to the 8, and 5 is going to go up to the z. So ln 8 to the second power plus ln z to the fifth power. To the 8 to the second power, I actually want you to do the math. So ln is 64 plus ln z to the fifth. We can show you our final answer is ln 64 z to the fifth. You multiply them when you put them together. Okay. Next one, we're going to solve for x. So here I have 2x in the exponent. I can't do anything until I get rid of the base. So I'm going to move the e over here. So 2x equals ln 0. Now remember this property. If you have a log that's 0, that means it's going to equal to 1. So I can rewrite this as 2x equals 1. So x equals a half. And it makes sense because if I plug in a half here, this will be e to the 1 power. Wait a second. Did I mess up?
I don't think you can do ln 0.
What was my property at ln 0?
ln1 equals 0.
ln 1 equals 0. My fault. This is actually unsolvable. This was supposed to be 1 over here. Now I'm remembering. I remember thinking about that last year too. Okay, this is supposed to be a 1, which means let's pretend this was a 1, which means this would be ln 1, which means the thing I wanted to happen would work. 2x equals 0, so x equals 0, and it would make sense because e to the 0 power equals 1. Okay, my fault on that. I feel like I remember that error last year too. All right, next one. E to the 3x equals e to the 2x minus 5. Well, because they're both e's and exactly the same, I could cross them out because they exactly match. So then I just have 3x equals 2x minus 5. X equals negative 5. The reason I could cross them out because what I'm officially doing is putting ln on both of them, and ln e will cancel out. So that's what I'm officially doing.
Any equation that has the same base.
Absolutely.
So then the next one.
The next one does not have the same base.
You can make it have the
So you
same
make it
base.
6 to the third.
So there's 2 ways to do it. You could do 6 to the 5x equals, rewrite 216 as 6 to the third. Then cross them out, and you'll have 5x equals 3, x equals 3/5. Now that works if you realize 216 is a 6 to the third. If you don't realize that, you could still take, let me do it over here. You could do this and use logs to our advantage. Take the base of log, or base of 6, move it over here. So 5x equals log base 6 to 16. Then you could put in your calculator log base 6 to 16, which happens to be 3, match what we said earlier. And then x equals 3/5. So just in case if you don't remember, you could always use logs to solve it. Number 12. In order to solve this, we need to make sure we combine like terms, or combine the ln's before we get rid of the ln. So here we're going to combine the ln's. So it's going to be ln x times x plus 3 equals 1. We don't like the ln being here, so I'm going to move the ln to the other side, which means it's going to become an e in the process. So x plus 3 equals e to the 1 power, or just e. We could FOIL out the x squared plus 3x, subtract the e, but this is not this is impossible to do, so we will just leave it like that. Or we would need a quadratic formula. I don't want to use a quadratic formula or something crazy like that. Okay. All right, next one, function. If you remember this is from your tests. What date? I said December. So here, when we see f and there's a number, we just take that number and plug it right in. So 4 squared minus 4 equals 12. If we see they're plussing to each other, we rewrite them both separately. So g of x, which is 3x plus 5, plus f of x, over here f of x squared minus 4. Then we could just combine like terms, x squared plus 3x plus 1. What about the other x?
That's just saying
That's just saying, yeah.
Let's say you leave the X in.
Yeah, you're not replacing the number at all. It stays as is. Now GH, just like this, means G times H. So that's going to be 3x plus 5 times x plus 2. You're going to have to FOIL. So 3x squared plus 6x plus 5x plus 10. Combine some like terms. 3x squared plus 11x plus 10. I did that pretty quickly. You can look at it for a little bit. F of g, good. So it's f of g of x. So it's a composite function, one inside the other. What's up?
G goes into the F.
G goes into f because f of g. Okay. So g is going to be replaced with what it is, which is 3x plus 5. So f 3x plus 5. Now that 3x plus 5, I'm going to plug it into every instance in f of x. And it only happens once, but it happens in a square. So it's going to be 3x plus 5 squared minus 4? Minus 4. So that minus 4 just stays around. Remember, do not distribute the square. You have to rewrite it and FOIL it. Like 3x plus 5 times 3x plus 5. Or remember the pattern of it.
Is this calculus or pre-calculus?
This is pre-calculus. Next chapter we start actual calculus. Oh. 9x squared plus 30x plus 25 minus 4. Combine like terms. 9x squared plus 30x plus 21. Yes, you could take out a 3, but that's not necessary. I just asked you to simplify. If I asked you to factor afterwards, then maybe, but I did not ask you to do that. Last one, g of h of 5, of negative 5. So g of h of negative 5. So we're going to replace the h over here with g of, when you plug in an h into, a negative 5 into h, negative 5 plus 2. So g of negative 3. Then I take the negative 3, plug it into my g, which is 3x plus 5. So 3 times negative 3 plus 5. Negative 9 plus 5. Negative 4. All right. This thing, get used to the look of it. It's a difference quotient. You're going to have definitely a question like this. So this one,
Give us the difference quotient on the side.
when the problem shows up, it will have it next to it, yeah. So we're going to use this. So this means f of x plus h. So I'm plugging in x plus h into the x squared. So that's x plus h squared minus f of x, which is just x squared.
Why? I thought it was just x squared plus h. Why is the whole thing squared?
Because you take this thing, x plus h, where every x is. You replace it as is. So it becomes x plus h squared.
Are you giving us the formula on the test?
Yes. And Either it's going to be x or a number. I find the numbers a little easier, but it doesn't matter. Okay, so here I have to distribute the thing. Remember, it is foiling. So it should become x squared plus 2xh plus h squared minus x squared all over h.
You would not accept it if it's modern day, so I can get into Scarlet. It's like
Then,
not like a U. It's like a,
2xh.
no, I mean the part
You
where
can take away all these.
uh-huh.
And then 2x plus h.
Good. So after I simplify the x squares, I can take out an h of everywhere. So I'm left with 2x plus h. You will learn later there's a way to eliminate the h, but that's chapter 2.
But I want to learn. You like
That's
answer. Now you have to
fast.
tell us.
It's going to be evolving limits.
Aiden loves limits.
All right. I guess I had this again. Doesn't matter. Square root x is our base function. This means inside the square root of x, there's a minus 4. So that means I got to go right 4 and then down 2. Remember, inside, it flips your idea.
Where'd you get the root x?
I said based off the parent function, but on the test I will write compared to root x.
Oh,
Okay? And this is
I'll say that.
is going to be a flip,
vertical.
vertical flip. Flip. We're going to go left 2, and we're going to go up 3.
And parent function is just what's it? What?
Well, absolute value, good.
So that's just what it looks like.
This is the parent function, and I will draw the parent function, or not draw. I will give you the parent function based off it, like so you don't have to. But it's usually obvious because there's only one thing that's happening to it. All right, number 9, find the inverse of the following function. So here in this case, we're going to change this to a y equals 3x minus 2. Swap the positions. X equals 3y minus 2. Do a little solving. x plus 2 over 3 equals y, or aka f of negative 1 x. Number 10, 4x squared. In this case, we could try y equals 4x squared. Swap it, x equals 4y squared. Divided by 4 on both sides, x divided by 4 equals y squared. Square root both sides. The problem is when I square root both sides, I technically have to square root x over 2 plus or minus equals y. So in this case, there is no inverse. So you say no inverse.
Wait, what happened to the square root of x?
This it should be a square root of x, you're right.
Well, it doesn't matter. It's plus or minus.
But as soon as you notice the plus or minus, or you could probably notice because it was a parabola, it was going to be no inverse, or what we call an even function.
When is our test?
The 3rd. But Monday or Wednesday, your college essay. Thursday we meet. Friday's evens.
So next month.
Next Monday.
Oh, no.
Monday.
I thought it was Thursday.
I spent 20 guys, I could travel anywhere, literally I travel.
Okay.
Is that the Maryland supplement?
Oh wait,
yeah. I already have an answer.
did we do it? Oh,
I answered that one.
all right. Let's keep going.
I left the Wednesday one.
So the absolute value function looks like this. The absolute value function looks like this, which means normally its domain is all reals, so negative infinity to infinity. And its range is usually starting at 0. So normally it's 0, comma, infinity. In this case, because we're shifting it up 1, we could reason that our range will be different and be up by 1. Domain doesn't change because it still will be negative infinity to infinity. While my range is going to be a hard bracket at 1 now because I moved it up 1 to infinity.
What's the point of the graph, right?
This is the parent function to help you visualize. And this right here is the parent function's normal domain and range. This plus 1 causes the range goes from 0 to 1.
Gotcha.
All right. X cubed, I guess I could keep it up there. X cubed looks like this. The normal domain and range is all reals on domain. And also all reals in the range. Which means, even though I'm shifting it down by 5, the domain and range is still affinity to affinity. So the domain and range actually has no change.
It stops at a certain, like it doesn't.
No, it's getting wider. It's getting wider and wider. It just looks like it stops because technically it gets so much taller faster than it gets wider. It feels like it's straight up, but it's not actually. And then negative affinity to affinity. All right, the square root one looks like this, where the domain typically is a hard bracket, 0 to infinity. And the range is also a hard bracket, 0 to infinity. So in this case, since I'm moving left 1, that means my domain is also being moved left 1. So I would technically subtract 1 from both of these, which means I would have negative 1. And you technically subtract 1 from infinity, but that's still infinity.
Infinity minus 1.
Minus 1 because you go left 1.
Right.
Negative 2, we're going down 2. So that means I'm going to subtract from my range 2 from both of them. So negative 2, comma, still infinity, because taking 2 away from infinity is still infinity. Yes.
What?
You know this is recorded. Like that's just like been immortalized what you just said.
That's enough.
I want it on the recording.
So this is
That's enough.
clearly it's a parabola x squared. What's wrong with you?
Scarlet.
So now, usually our x squared is over here, right?
It's flipped.
Negative.
So there's a couple of things happening. One is definitely flipped. So I know I'm going to have a negative in front. It was moved to the left 3 times. So I needed to move to the left 3 times. So it's going to be x plus 3 squared.
This is the end of first period. We are working on our bell.
And then plus 1 to move it up. So it'll be 1 up here, okay?
Shinar, Shira, Alicia, please.
Yeah, well, let me just do it right now anyway. So here, it would be, this is technically x cubed, which normally would be here. It looks like it just shifted to the right 2. So x minus 2 to the third power. Yeah, and I said no stretches or shrinks.
If we know everything in the packet, we're good for the test.
And a little bit of the book too. So I have a question like, you remember like in book question number 1, it says like f of negative 1 of 2?
Oh yeah, that's like we did print. That's like
Yeah. It's still in the concept, yeah. But that exact question is in the book, but technically not in here. So I just want. There's one. Yes, there's a word problem. It's a double life problem or a half life problem. So that is not your packet. I gave it out yesterday.
Do I have one? Was I here yesterday?
You were here yesterday. You were talking with